G'day. Today I was making a bit of tooling up which I thought might be of interest to you. It's a thing called a t-dolly, and it's used basically for sheet metal work. The way a t-dolly is used is basically round something or other over the top, and then you can use that with a hammer to beat that. If you need to work on a corner round that over, you can use the ends. I guess it's something similar to what an anvil horn is to a blacksmith. It's one of those things that every so often I wish I had, and the other day I thought, well, let's go do it. So this follows how I made it. This bit is pretty straightforward. It's just a little bit of welding, so I don't show much about that. But getting this shape out of a lump of steel with no centre holes or anything like that was a bit time consuming. So yes, this is the story. This is the main challenge of this part. That's diameter 50 at the moment, and it's in its as supplied state. I need to take that down, or I want to take that down to 45, so I can fit inside a 50 diameter tube. I also want to dish the ends, make them hemispherical, both ends. This is my 3-jaw chuck. It's relatively new. It's pretty solid, but the stick out I've got here is, well, if that's 50mm material, maximum stick out 3-to-1 rule, ends about there somewhere. Putting a dome on the end is going to put a lot of pressure on, sideways pressure. I'm going to get all sorts of chatter. So what I'm going to do is come along with a, well, I'm going to use a parting tool, but basically clean up this bit in here. Once I've got that in a fixed steady, I can then come along with my radius turning tool and round that off, flip that over, do the same thing. Now I'll need to take that down to 45 here so I can get a decent finish, but then it's a matter of grabbing that and then doing some cleanup in the middle, which shouldn't be too onerous, but we'll see how we go. What I hoped wouldn't happen has happened. I started out this cut just to take a bit off with the parting tool, and that cut in, but towards the depth I was going for, I started getting a bit of chatter in. I've had to slow the speed right down to about 80 RPM, which is not, actually no, it's 60 RPM looking at the speed dial, so it's even slower than that. What I've done is grabbed hold of one of my usual tools, normal, knife tool, and I've used the basis of that as a starting point, and I've gone along and I'm getting a much smoother finish. So I'm going to have to do that, unfortunately. I would have preferred just to be able to plunge in there, but I can't. But at least I'll have a surface then that I can run my steady on and not have to worry too much about it ripping the steady up or chattering. But this is a problem with long unsupported bits of stuff. Some people might be asking, why don't you put a centre in there and put a tailstock support in there? I could do that, except that when I come to put the dome on there, I don't want to have to take off the 5 or 6mm worth of material on each end to get clean up, because I want that hemisphere to be relatively smooth. So another possibility is to make up a sort of a spider with a centre in it. Could have done that, but this is the way I'm choosing, so we'll see how this goes. Using the steady, I've managed to clean up my ends. I'm still using a 3-jaw chuck at this stage because I can't run an indicator across this and work out where I am yet. So all I've managed to do is clean these up and get these down to my finished size, 45mm. Then I'm going to do a little bit of a bodgy setup to clean up this inside piece. Once I've done that, I can then bring this setup back and dome the ends, not a problem. A couple of things to note. One is that chip breakers, carbide tools usually have chip breakers on them, but they only seem to work on certain speeds and feeds. So when you've got chips coming off like this, I mean, these are pretty strong chips, they're hot, they're sharp, and some of them are coming off longer than this. What I tend to do is interrupt my longitudinal feed, just a quick blip, just to break the chip. Particularly if it's sort of started heading towards you, If it's going down into the bed there, I don't get so concerned about it, but if it's starting to come over this way, I break it off so that I don't have a problem with a potentially hot, sharp chip whipping around the place, particularly if it gets caught in a chuck or something like that where it suddenly starts doing all sorts of things. Speed I'm up to around about 164 RPM, so an improvement on the 60 that I was doing before, but it's still slow going. This is an alloy steel, so it's about half the speed of you do for mild steel, but also because I'm in a steady and I'm trying to avoid chatter and all that sort of thing, that's part of the equation. I'd like to get, if I can, a reasonable finish on here, so I minimise any polishing and all that sort of thing I have to do. Welcome to the setup I'd prefer not to have to do. I guess the thing about setups like this is that while they should work, they're outside of most people's experiences, and so you always feel a little bit nervous about it. In this case, I've swung my comp round 90 degrees. I've put a boring bar holder here, and this isn't my normal boring bar. Normally I've got one that goes to the left, which is fine for boring holes. This one actually goes to the right. I bought it for things like this in case I needed to do a pass. I would prefer to be cutting into the chuck, because if you cut out to the chuck with something like a steady, you run the risk of pushing the work out of the chuck, which is could be disastrous. I've swapped to a smaller chuck so that I've got clearance over my cross slide here, and I actually had it in neutral and was spinning it around by hand just to check that I did have that clearance. So I've got about an inch or so, 30 millimeters of travel from here. So I'm going to try and whittle away this piece of metal in the middle here and to see how we go. I may have to end for end it, I may have to readjust things and more stick out or less stick out or something, but we'll see how we go with it. Things aren't going too badly. I'm running this tool across to meet up with this surface here. With respect to machining away from the chuck, I've got a block here that I made up many years ago, decades ago now. It's basically just plywood. It's got the inside of the centre in one end, and the other end is just flat, and so I'm using that basically as a pressure pad just to make sure that this doesn't want to try and pull out of the chuck as I'm cutting there. The idea is going to be that I can clear a space here, then I can swap over to the other tool and then start working my way back this way, and that's usually the way I go. Temptation when doing this sort of work is to just look at the cutting tool, but you do need to look everywhere else. For example, I was going along and I discovered that I was about to hit the steady with my tool holder, so I had to stop, extend that out a bit and go from there. Similarly, when I first started off, I didn't have this in here, and discovered that things were chattering and vibrating a bit too much. But we're getting there. So yeah, the plan is basically to meet up with that diameter there and then work back. I'm now at a stage where I've cleaned up that middle bit. There's a little bit of marking there, but I think I should be able to polish that out. It's not terribly deep, and the amount of travel I've got between the cross slide and the steady is only about 30 millimeters. What I've had to do with this is basically wind that up to about there, engage the cutting tip, engage the travel, move along till I got to the end of my travel, stop, and then loosen off my cross slide, slide it back, slide it forward into the start of the cut so that I can travel another 30 millimeters. It's not the best. It's certainly not accurate to size. I've got 0.1, 0.2 of a millimeter difference over there. I did have a dig over here when I ran this into ran the carriage into the steady, so I've had to take that down, so it's now 44 nominal rather than 45, which is a bit of a pity, but again, that's the way it goes sometimes. What I'm now going to do is break this setup down and turn it back to something like a normal lathe. Get the carriage from out between the steady and the chuck, put the carriage over here, put the steady on here, and then I can come along with a tool, take this end down to size, and then start putting the radius on, flip it, and do the same there. I'm probably a couple of millimetres worth of feed in before I get the dome on this end. I've already done this end, and that worked out reasonably well. Gave it a bit of polish and all that sort of thing. I've had to go back to a 3-jaw chuck here. The 4-jaw just didn't have the depth of jaw. That's not such an issue here because it's not a precision part as such, and the steady will tend to keep the part centralised. I've got some copper in the jaws so I don't scratch this up too much. Once I've got the ends to form and polished up, I'll then put a trench in, then weld the bar in. So it's once this bit's done, it's probably 80% of the way there. I have the top of the dolly centered up here in the vise. I'm now going to put a trench in there. I've got a bit of 10mm plate, and I'll just make that trench that wide, pop that in, only a short bit, only you know, probably 5-10mm, just to bed it in. History of a woodworker, you know, a rebate joint is always better than a straight butt joint. I'll then just weld around the outside. I'm not expecting to be belting this thing until next Tuesday, but I do want it strong enough that it's not going to move and crack on me. This is going to sit in the vise on the bench. Now, I don't really like the idea of if this thing moves down, it puts a lot of pressure on the bottom jaw, the moving jaw. So what I've done is I've got a bit of strip, put in some holes with countersinks. I'm now going to cut that in half with the anvil grinder, and then I'll just weld that on there, that side, the other half on the other side, neaten that up a little bit, and that way I've got basically a stop which will rest against the fixed jaw, and by default the moving jaw, but it'll rest against the fixed jaw, and hopefully that'll stop it. When welding something like this on, this is going to be okay because I'll cut it in half, but the best you're going to get in general terms for penetration for weld is about 3mm, 1/8 of an inch. So you really, if you're going to do this sort of thing, you really want to get that thickness down there so it is about 1/8 of an inch or less, and that way, you know, you should get some decent weld in there. If you have that countersink too small, you'll tend to find the weld will sit inside the countersink and won't actually get down and touch the material you're trying to weld to. And here is the finished dolly. I've welded the plate on there. A long time since I used sticks, so I'm a little bit rusty there. The pieces here, you can see I didn't quite fill up the top there, but that's okay because I've got penetration down to the bottom, and this side is similar. So that just lets that sit there like so. I need to give this a bit more of a polish because the smoother this is, the less marking on the sheet metal, but that's minor. To machine those things and get both sides the same, use a little clamp which I think I saw on Ox Tooling, but that just clips onto the vise and then acts as a stop for that to run up into. So that's a worthwhile thing if you've got a few hours one day and are looking for a small project. So anyway, that's the T-dolly. There you go, a piece of tooling which is, well, I won't say rarely found for sale, but not all that common. So I hope that was instructive. Please share if you like what you see, and thanks to who've inspired me.